Okay, the time has come to pay really close attention because this is one of the most important things to remember in all of high school math. It is called the distributive property, and once you learn it, it is hard to go a day in math class without using it. It is here forever. It is extremely important. We love it. We use it. It is great. But when you get started, it can be a little bit confusing, which is fine. Remember, why are we trying to do work with variables? It's so that we can make progress and play with stuff and find out what might be true, even in situations where we don't know what all the numbers are yet, or even we'll never know what all the numbers are. So that's what the purpose is for. Now, the problem with doing that is, so before we learned how to multiply things, so I could take 3x times negative 6x squared, and I know that first I do the sign, positive times a negative is a negative, then I do the number, 3 times a 6 is 18, and then I do the letters one at a time, so I count up the x's, 1x from there, 2x's from there, that's x cubed. So you learned how to do multiplying. We learned how to collect like terms. So 7y minus 3y plus 2, and that is 4y plus 2. So that is tremendous progress. So we can make things simpler, right? By simpler, I mean they take up less space, and if somebody were to calculate them, they would do it in fewer steps. So think about how many steps this would be on a calculator if I knew that y was 12, versus how many steps this is on a calculator. I have made it faster, I have made it simpler. But what would seem to get in the way of that is brackets. Because remember, if you put something in a bracket, there, the rules for BEDMAS say that that thing for brackets has to happen first. And how can I work out what's in the brackets if they will not tell me what x is? So this is where the distributive property comes to the rescue, and it is our ultimate cheat around BEDMAS. It basically, not all the time, it allows us to get around brackets most of the time. And there's an example you probably already know when you first learned the formula for area of a rectangle. So we're going to have a rectangle, it's going to have a length, and it's going to have a width, and the formula for area. Now here's the problem. You might have learned two of them. Some students might have learned that it is 2L plus 2W, whereas some other students might have learned that area was equal to L plus W times 2. Now, if you think about them, they are both the same. It does not matter, so let's look at this one. So I take 2 of these added together with 2 of those, and that will, hold on, leaving that in because nobody's perfect. That's not perimeter, that's area. Sorry, that's not area, that's perimeter. I'm still leaving that part in because nobody's perfect. Anyway, doing the perimeter, so 2 of those plus 2 of those is the same number as this plus this, but then twice. Both are correct and both are the same. And that is because even if you have brackets, very often there is a way to write the same thing without brackets. So having something plus something then multiplied by 2 is the same as adding 2 of the something and 2 of the something. So I'm going to write the ever important distributive property, which is something times something plus something is the same thing as the first something times the something plus that something times the other something. And the way we think of that that makes it easier to visualize is it's called the distributive property. You want to think of somebody giving away Halloween candy or Valentine's Day cards or something. We think of this A as being given to everything inside. The A has been given to the B, and remember there's a little time sign here that you don't see, and this becomes A times B. The A has been given to the C. This is A times B. It's been distributed. Okay? Now, actually what we do very often is we will draw the lines. And I have been doing this for a long time, and I will tell you honestly, the lines help. The lines add clarity. You never, ever, ever get too old to draw the lines. Some people go a little bit far. They put little arrows on top of the lines. That is a little bit too much. We don't have time for that. We have lives to live. We have to get on with that. But that's that. So let's just look at some examples, and you'll see this is going to be very, very straightforward with a couple of exceptions that might trick you up. So let's have, how about 3 times x plus 2? Well, I'm going to distribute the 3. And remember, I keep what I'm thinking very straight. Even though I didn't write a times sign in here, I said times to myself as I was writing. So even though we might take shortcuts in the interest of just getting the writing done a little bit faster, it's important that you don't take shortcuts when you're thinking about stuff. Anyway, so I distribute, so 3 times x plus 2 becomes 3 times x plus 3 times 2, and I am old enough to do 3 times 2 in my head. That's 6. So let's do another example. How about, we'll take a variable. We'll do a times a plus 5. So again, I'm going to distribute. So a times, when you have multiplication butted up against a bracket, it just leaps into the bracket and spreads over, kind of like an infectious disease. So this is a times a. Well, we know that a times a is a squared, and a times 5. Well, when you have two things, when you have variables multiplied with stuff, you don't calculate anything, you just keep a record of that's what you were doing. So a times 5 is 5a. That's it. What about if there's a negative number inside? So how about 6x plus, I want to make this one a little bit harder, 3x minus 4. Okay? And so when I go through and I distribute, six times 3x, again, it's more complicated, but I can still do it in my head. I do the sign, a positive times a positive is a positive, the numbers, 6 times a 3 is 18, and then I just bunch up the letters. Here there's just an x, like that. Now 6 times negative 4, that's going to be negative 24. Okay, let's keep making the examples a little bit harder. So how about 2x, 3x minus 5? Okay, so again, distribute. And what often happens when people are in a hurry is this one they can remember, but if you don't draw the line, sometimes the second one you forget. I'll show you what I mean. So 2x times 3x, do the numbers first. 2 times 3 is 6, do the letters second. X times x is x squared. Okay? If you're in a hurry and you haven't drawn the arrows, or the lines, or whatever you're going to call them, some people will write just minus 5, like they will forget that they were supposed to do anything to it. But no, when you had this thing with the area, both of them had 2's, right? So that's an important part of it. And I want not negative 5, but 5 times 2 is 10, and x is an x. Okay? Now we get into what to do is, what if there is a negative? So I'll do the easiest example first, and actually let me do an example with numbers so you understand what's going on. What about I have negative 5 plus 9. Okay. So let's say this negative is I owe somebody some money because I borrowed something last week, whatever. So I owe them 5 and I owe them another 9. So one way of doing the question is to work out that if I owe them 5 and another 9, I owe them 14. And because I owe them 14, that's negative 14. Another way to do it is to separate it, to think I owe them 5 and I owe them 9. And if I owe them 5 and I owe them 9, I still owe them negative 14. So it doesn't matter which way we're going. How does that work with a variable? So I would have negative, let's go different letters, b plus 3. Well, when you use the arrows, this is subtract. There's two ways to think about this. They're both correct. I think this is the slightly more the less confusing one takes more time, the more confusing one takes less time. Both give you the same answer. So really, this is negative 1 times. So having a negative in front of a bracket is the same as having negative 1 times what's in the bracket. That's just sort of how numbers work. So when I distribute, it's just everything inside times negative 1. So how about negative 1 times b? That's negative b, and negative 1 times 3 is minus 3. So you'll see this question, this happen in questions a lot. Really easy to do. You have a negative in front of two things in a bracket. Both of them become negative. Easy. Okay, what about negative d minus 6? Okay, so distribute. I won't put the 1 in this time, but if I won't put the 1 in, if you think writing in the 1 makes it make more sense to you, you can put it in, and eventually you will just kind of get the hang of it and you will stop writing the 1. Now, does that happen in a day, a week, a month? I don't know, but if it makes it easier to understand and you want to write it a long way, go for it. No one's going to stop you. So that will be negative d, and negative times negative 6, negative times negative is a positive, so plus 6. So really what's going on is if I have a negative in front of a bracket, everything inside changes sign. So d becomes negative d and negative 6 becomes positive 6. The other thing that you have to always keep in mind is that if I have, this has numbers in it, so this doesn't count. If I have two things inside the bracket before I distribute, there are two things after I'm done. Two things before, two things after. So how about if I try 3x, x plus y plus 7. Okay, now the same thing is true, and now I have 3 lines. So now I have 3 times x, this is 3, and x times x is x squared, plus 3x times y, so that's just 3, and I just add in the letters. There's an x and there's a y. So 3x times y, which is 3 times x times y, is the same as 3 times x, is the same as 3 times x times y. When I don't know what the numbers are, multiplication is really easy because the answer to the multiplication question is to write it as a multiplication question. And then 3x times 7, you'll see that is 21x, something like that. What about if I have, say, a negative 4, let's write that there, x squared minus 2x plus 6. Okay, I'm running out of colors here, but that's all right. So negative times a positive is a negative. 4, this one is 4, is x squared is x squared. The next one is negative times negative, which is a positive. 4 times 2 is 8, and then there's that x. This is a negative times that positive, which is a negative. 4 times 6 is 24. And remember, I had 3 things before inside the bracket. I gave something to all 3 of them, but I had 3 things left over when I was done. Now, one last one. We'll do a nice combo question. So let's say I have 3x plus 2 minus 5x minus 1. Okay. So Now I just have to do the thing twice. Distribute, 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 distribute. So I'm going to take the same rule, make it more complicated, and it won't be any more difficult as long as I take my time. And I put in the arrows beforehand, so hopefully I don't forget any steps. 3 times x is 3x. 3 times 2 is 6. Negative 5 times x is negative 5 times x. See, multiplication with variables is easy. Negative 5 times x is just negative 5 times x. And negative 5 times negative 1 is plus 5. Okay, now I can kind of sort of keep track. These two have x's, and these two have numbers. So I can put the numbers together. 3x minus 5 minus 2x, and 6 plus 5 is plus 11. So hopefully that gives you an overview. We're going to be using the distributive property all the time. In fact, the next video we're going to use a much more challenging version of the distributive property. It starts to get a little bit confusing a lot fast, but good luck with that. As always, if there are like specific questions in the homework you think this is challenging, leave either the text in the comments below or send us an email to questions@mathhomework.ca. We try and get answers up for most of them as soon as we can. And thanks very much, and good luck with your math homework.